Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Dr. Humayun from Peshawar. Today, I will discuss chapter number 2, atomic structure. The topic for today's discussion is Bohr's model of hydrogen atom. Bohr's atomic model. Dear students, Rutherford was a scientist. He proposed a model known as Rutherford atomic model. That model laid the foundation for the structure of atom. But remember students, there were some discrepancies in the Rutherford atomic model. To remove that discrepancies, Niels Bohr introduced another model that is known as Bohr's atomic model in 1913. So in 1913, Bohr proposed a model known as Bohr's atomic model, and the main postulate of the Bohr's atomic models are main postulates. First postulate is electrons revolve around the nucleus and fix paths, circular paths called shells. Electrons revolves around the nucleus and fixed circular paths called shells or energy levels Right students, the second postulate of the Bohr's atomic model was electron do not emit or absorb energy as long as it remain in the same orbit. Electrons do not emit or absorbs energy as long as it is present in the same shell. Let me explain these two postulates, then I will proceed. The first postulate is electron revolves around the nucleus and fix circular paths called shells or energy levels. इसका मतलब है कि इलेक्ट्रॉन जो है वो फिक्स सर्कुलर पाथ्स में रिवॉल्व करते हैं and we call that energy level or shells. Next one is electron do not emit or absorb energy as long as it is present in the same shell. इलेक्ट्रॉन ना तो एनर्जी लूज करता है ना एनर्जी गेन करता है जब तक वो उसी एक शेल में मौजूद होता है. तो this is nucleus, positively charged. These are the circular paths. These are the circular paths called shells. Right? Electrons are here, exist. Right? Or here. In the first shell, 2 electrons, 8, and so on there. So these are shells or energy level. If electrons revolve in this shell, it will not lose or gain energy in this shell. Right students? When electrons lose energy, when electrons lose energy, it jumps from high energy level to the lower energy level, to the lower energy level. And when it gains energy, it jumps from lower energy level to the higher energy level, to the higher energy level. This change in energy is in the form of h nu. h nu. Looks to this. अगर हमारे पास इलेक्ट्रॉन यहाँ पे है और इनको बाहर से एनर्जी मिल जाती है, so this electrons jumps from lower energy shell to the higher energy shell. या अगर इलेक्ट्रॉन ये एक्स्ट्रा एनर्जी लूज करती है तो इट विल go to the lower energy level. And remember, this change in energy is equal to E2 minus E1, which is equal to h nu. अगर सिंस ये E1 है तो ये क्या होगा? It will be E2. And remember, E2 has more energy than E1. And this change in energy is in the form of h nu, mean photon or quanta or energy packet, and one energy packet is h nu. Right, student? Now next point is number 4 point is the energy of electron. The energy of electron in an orbit or shell is related to the distance from the nucleus. The further the electrons away from the nucleus, the more it has the energy, the more it has the energy. इलेक्ट्रॉन न्यूक्लियस से जितना दूर होगा उतना उसकी एनर्जी क्या होगी? ज़्यादा होगी. It means that electron near to the nucleus has less energy than electron which is far from the nucleus. इसलिए यहाँ पे मैंने कहा कि E2 has more energy than E1. And the energy of electron is quantized. The energy of electron is quantized. मतलब है स्टूडेंट्स के इलेक्ट्रॉन या तो शेल नंबर 1 में होगा, शेल नंबर 2 में होगा, या शेल नंबर 3 में होगा, या 4 में होगा, but it cannot be between the two shells. Remember, in the electron की specific energy होगी which is related to its shell. If it is shell number 1, इसकी एनर्जी शेल नंबर 1 के मुताबिक होगी. If it is exist in shell number 2, so its एनर्जी जो होगी वो शेल नंबर 2 के मुताबिक होगी. जितनी शेल नंबर 2 की एनर्जी है उतनी इलेक्ट्रॉन की एनर्जी होगी. जितनी शेल नंबर 1 की एनर्जी है उतनी इलेक्ट्रॉन की एनर्जी होगी. but it cannot exist between the two shells. इसलिए हम कहते हैं कि the energy of electron is quantized, and the angular momentum of electron is the integral multiple of nh by 2 pi. The angular momentum of electron is equal to mvr is equal to nh by 2 pi. मैंने लिखा है the energy of electron is quantized. उसके बाद मैंने लिखा है the angular momentum of electron is the integral multiple of nh by 2 pi. nh by 2 pi is n. I told you energy of electron is quantized. N can be 1, 2, 3, 4, but it cannot be 1.5. It cannot be 2.5. It cannot be in fraction. तो इसलिए इस सिंपल मैंने लिखा है कि the energy of electron is quantized. And angular momentum का फार्मूला है mvr is equal to nh by 2 pi. M is the mass of electron, v is the velocity of electron, r is the radius of atom, h is the Planck's constant, and pi is the constant and the circle. अगर आप एक सर्कल ड्रा करते हो तो circumference divided by diameter is equal to pi, which is also a constant. So the angular momentum of electron is mvr is equal to nh by 2 pi. Students, these are the main postulates of Bohr atomic model. Inshallah, in the next lecture we will discuss the application of the Bohr's atomic model. Okay students, so let's proceed to the next topic, and the next topic is applications of Bohr's model of hydrogen atom. And in the application we will derive first the radius of a hydrogen atom. So the first topic is the derivation of radius. It is one of the applications of the Bohr's model of hydrogen atom. Now according to Bohr, that an electron being 1836 times lighter than proton means proton is 1836 times heavier than electron, so it remains stationary in the nucleus while electron revolve around the nucleus in fixed path called shell. So let me draw the diagram. This nucleus, it has a atomic mass of Z and the charge is E. So Ze is the total charge, while electron, the charge on the electron is E. Right students? And the force of attraction between the proton and electron is called force of attraction, Coulombic force. Now let's consider hydrogen atom. Having one electron, having a single electron. Proton remain, you know that it has one proton and one electron, there is no neutron, and as proton is heavier than electron, so it remains stationary. Proton remains stationary, proton remains stationary, and the nucleus while electrons revolves around the nucleus in shells. Right students? No. The force of attraction between the electron and proton is Coulombic force, and you know that according to Coulomb's law, the force of attraction or repulsion between 2 point charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. कूलम्स लॉ कहता है कि जो फोर्स ऑफ अट्रैक्शन या रिपल्शन है बिटवीन टू चार्जेस, वेदर इट इज अट्रैक्शन और रिपल्शन. अट्रैक्शन और रिपल्शन का मतलब है कि अगर हम सिमिलर चार्जेस की बात करें या अपोजिट चार्जेस की बात करें, तो अगर सिमिलर चार्जेस है दे विल रिपेल ईच अदर, और अगर डिफरेंट चार्जेस है सो दे विल अट्रैक्ट ईच अदर, एंड दैट फोर्स ऑफ अट्रैक्शन और रिपल्शन इज डायरेक्टली प्रोपोर्शनल टू द प्रोडक्ट ऑफ देयर चार्जेस. दोनों चार्जेस का जो प्रोडक्ट है, and inversely proportional to the square of distance between them. So I can write Coulombic force F is directly proportional to Q1 Q2 divided by R square. इसको किस तरह लिखे स्टूडेंट्स कि the force of attraction or repulsion between 2 point charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. In this case, let Q1 is ZE and Q2 is E. This is the charge in the nucleus and this is the charge on electron. And let's put this in the equation, so it become F is equal to ZE into E divided by R square. R कितना है? This is R. और simply I can write F is equal to K Z E square divided by R square. What is K? K is called proportionality constant. Proportionality constant. And this K is equal to 1 by 4 epsilon naught 1 by 4 pi epsilon naught 4 pi epsilon naught. So if we put this in place of K, so this equation becomes F is equal to 1 by 4 pi epsilon naught, right students, into Z E square divided by R square, where epsilon naught is called permittivity constant. It is known as permittivity constant. And students, permittivity constant इसकी जो वैल्यू है वो है 8.854 into 10 raised to the power minus 12 coulomb square Newton inverse meter minus 2 meter minus 2. This is the unit of this is the value of epsilon naught. Epsilon naught is equal to 8.854 into 10 raised to the power minus 12 coulomb square per Newton meter square. हम इस तरह ले सकते हैं coulomb square per Newton meter square. Alright students, and what is permittivity constant? It is the ease of electrostatic force to pass in the free space. ये वो amount of electric force है जो कि free space में pass हो सकता है. The ease to pass the electric force in the space, that is epsilon naught. Right students, now हम आगे बढ़ते हैं. Okay students, now students, we know that centripetal force is the force which compels the body to rotate in a circular path. This centripetal force, also known as electrostatic force, is balanced by the centrifugal force. And you know that centrifugal force is equal to F is equal to centrifugal mv square by R. And we know that the electrostatic force F is equal to Coulombic is equal to 1 by 4 pi epsilon naught into ZE square divided by R square is equal to this. Now we know that the centripetal force, the Coulombic force is balanced by the centrifugal force. So F centrifugal is equal to F Coulombic, क्योंकि ये बॉडी जो है centripetal force is the force which compels the body to rotate in a circular path, और ये तब होता है जब इलेक्ट्रॉन और प्रोटॉन के दरमियान ये प्रोटॉन है, ये इलेक्ट्रॉन, इनके दरमियान फोर्स ऑफ अट्रैक्शन है, और इस फोर्स ऑफ अट्रैक्शन की वजह से इसका मास ज्यादा है तो ये ट्रांसलेशनली एंड इट रिवॉल्व अराउंड द न्यूक्लियस, और ये जो फोर्स रिस्पांसिबल है दैट इज नोन एज centripetal force. And remember student, when the centripetal force is equal to the centrifugal force, then the body rotates in a circular path. So F centrifugal is equal to F of Coulombic, and we know that F centrifugal is equal to mv square by R, and F Coulombic is equal to 1 by 4 pi epsilon naught into ZE square divided by R square. Now students remember, यहाँ पे थोड़ी सी कटिंग हो सकती है. Look, this R is cancelled with this. This R I can write as R into R. So this R is cancelled with R. Remember student, R square means R multiplied by R, right? So I can write R into R, and I cut it to 1 R with this R. So this equation now. This equation is equal to now mv square is equal to, I will simply multiply this is ZE square divided by 4 pi epsilon naught R. I will transfer this R here and this mv square here. So मैं कर सकता हूँ ना, या सिंपली आप इस तरह भी ले सकते हो स्टूडेंट्स के cross multiplied. So from cross multiplied, simply you will get the value R is equal to, ये R यहाँ पे आ जाएगा और ये वहाँ पे शिफ्ट हो जाएगा. This is ZE square divided by 4 pi epsilon naught mv square. अब स्टूडेंट्स जरा यहाँ पे थोड़ी सी तवज्जो, बहुत इंपॉर्टेंट पॉइंट है, a very important point स्टूडेंट्स. देखिए स्टूडेंट, Z हमें पता है कि Z is constant. It is the atomic number of hydrogen, which is 1. That is the atomic number, right? Which is equal to 1. E is the charge on electron, which is 1.6022 and 10 raised to the power minus 19 coulomb. Again, it's also constant. 4 is obviously a constant. Pi is a constant. Its value is 3.14. Simply, epsilon naught is the constant. I told you before that the pi has a value of 8.54 and 10 raised to the power minus 18 coulombs, minus 18 coulomb square per Newton meter square. And but we don't have the value of velocity. Yes, we have the value of mass. The mass of electron. The mass of electron is 9.11 into 10 raised to the power minus 31 kg. Let me write Z is equal to 1, E is equal to 1.6022 and 10 raised to the power minus 19 coulomb. Pi is equal to 3.14. Epsilon naught is equal to 8.854 and 10 raised to the power minus 12 coulomb square per Newton meter square. Mass of electron is 9.11 and 10 raised to the power minus 31 kg, right? But we don't have this. So simply, just for a moment students, ये जो सारी जो वैल्यू है ये कांस्टेंट है. So I can write a constant K. मतलब क्या है? What does it mean? It means that when we put these values over here, so we will get a value, and that value will be a constant. It will be a number, and a number is constant. Let me write k, and over here into 1 by v square. Right students? अब देखिए जरा. Now when you remove a constant, you put proportionality sign. So r is equal, r is a inversely proportion to v square. ये बहुत important point है students. R is inversely proportion to v square. Yes. मेरे पास जो value आई, r is inversely proportion to 1 by v square. इसका मतलब क्या है स्टूडेंट्स? इसका मतलब है कि अगर हमारे पास इलेक्ट्रॉन की वेलोसिटी ज्यादा हो तो इसका मतलब है कि उसका रेडियस कम होगा. या मैं सिंपली आई कैन सिंपली से दैट द इलेक्ट्रॉन वेलोसिटी इज मैक्सिमम इन द स्मॉलर रेडियस. जितना हमारे पास रेडियस छोटा होगा उतनी इलेक्ट्रॉन की वेलोसिटी क्या होगी? ज्यादा होगी. जितने हमारे पास साइज ऑफ रेडियस ज्यादा होगा उतनी हमारे पास इलेक्ट्रॉन की वेलोसिटी या स्पीड हम कह सकते हैं कम हो. राइट? फॉर एग्जाम्पल ये हमारे पास शेल नंबर 1 है, शेल नंबर 2 है, शेल नंबर 3. इफ आई आस्क कि इलेक्ट्रॉन की वेलोसिटी कहाँ पे ज्यादा होगी, तो इलेक्ट्रॉन की वेलोसिटी मैक्सिमम यहाँ पे होगी, n is equal to 1 में. सो आप याद रखें कि द इलेक्ट्रॉन हैज maximum velocity in shells of smaller radius, in shell of a smaller radius. मतलब n1 shell number 1, in shell number 1 electron has maximum velocity. Right students? Okay. अब देखिए स्टूडेंट्स, यहाँ पे एक इम्पोर्टेंट टर्म डिस्कस करने जा रहा हूँ. लेट मी आई एम डिस्कसिंग अ वेरी इम्पोर्टेंट टर्म फॉर देयर, एंड द टर्म इज कि यहाँ पे वापस आ जाए, इस इक्वेशन की तरफ वापस आ जाए. r इज इक्वल टू, इसको मैं एक नाम देता हूँ, लेट्स सपोज दिस इज इक्वेशन a. R is equal to ze square divided by 4 pi epsilon naught mv square. ये हमारे पास इक्वेशन A, सिंपल. दिस इज इक्वेशन A. नाउ स्टूडेंट्स, यहाँ पे हम थोड़े से फासले से दूर है. किस चीज से? फ्रॉम रेडियस. अगर हमें पता होता कि व्हाट इज द वेलोसिटी ऑफ इलेक्ट्रॉन, इलेक्ट्रॉन की वेलोसिटी कितनी है, अमाउंट अगर हमें पता हो, शेल नंबर 1 हो या शेल नंबर 2 हो या जो भी शेल हो, अगर हमें पता हो कि इसकी वेलोसिटी क्या है, तो वी कैन सिंपली कैलकुलेट द रेडियस ऑफ दैट एटम. हम उस रेडियस को जहां पे इलेक्ट्रॉन रोटेट करता है, हम उसकी रेडियस को कैलकुलेट कर सकते हैं. बट अगर हमें क्या पता हो, इफ वी नो द वेलोसिटी, बट unfortunately we cannot calculate the velocity of electron when it rotates in a circular path. So what we do, we replace it by some factor, and that factor must have v square. हम इसको replace करेंगे एक ऐसे factor से जहां पे v square मौजूद हो, लेकिन उसकी जगह कोई और terms हो. For example, अगर हम इस्तेमाल करें angular momentum is equal to mvr is equal to nh by 2 pi. Taking square. If you take square, this equation becomes m square v square r square is equal to n square h square divided by 4, 2 to the 4 pi square. Now shift these two terms over here. अगर मैं इसको क्रॉस मल्टीप्लाई कर लूं तो ये दो टर्म्स जो है ये यहाँ पे शिफ्ट हो जाएंगे. So shift it to the other side. So v square becomes n square h square divided by 4 pi square and m square and this r square. Now we have the value of v square. Now if we replace the values of this v square and the equation, this one, so we will get the value of r. Now in this equation, right, if we put the values of v square over here, so we can get the value of r. How? So look students, now r अपनी जगह पे, r is here in its own place. This is z e square divided by 4 pi epsilon naught m and v square की जगह ये वैल्यू, v square की जगह ये वैल्यू, so v square की जगह मैं ये वैल्यू लिख रहा हूँ. So n square h square divided by 4 pi square m square r square. Rest मैंने क्या किया, I just put the values of v square from this equation. Students, this division है तो ये खुद ब खुद ऊपर चला जाएगा. ठीक है स्टूडेंट्स, इस तरह ऊपर जाएगा. देखो मेरे पास अगर एक वैल्यू है 2 divided by 2/3, तो मैं इसको लिख सकता हूँ स्टूडेंट्स 2 multiply 3/2. मैं क्या करूँगा, इसको मैं ऊपर लेके जा सकता हूँ. ठीक है, तो मैं क्या करूँगा स्टूडेंट्स, इसको मैं ऊपर लेके जाऊँगा. सो r is equal to z e square 4 pi square m square r square divided by 4 pi epsilon naught m n square h square. देखो स्टूडेंट्स, ये अपनी जगह पे रह गए. ये टर्म लिखेंगे, दिस टर्म ये मैंने यहाँ पे लिखा 4 pi epsilon naught m n square h square, और ये टर्म ऊपर चलेगी यहाँ पे z e square 4 pi square m square r square. ठीक है स्टूडेंट्स, अब स्टूडेंट्स मैंने अभी थोड़ी देर पहले कहा था, I just told you people that r square is equal to r into r. So I can simply write this r square, instead of this r square I can write r into r. Why? Because I want to cut one of the r. Now 4, look, this pi is cut, I can write this pi into pi, so I can simply remove this square. This m over here, so I have 1 is equal to z e square, and you can see pi m and r divided by epsilon naught n square and h square. Now cross multiply epsilon naught n square h square is equal to z e square pi m and r. Now I need the value of r. I need this r. I am searching for this r. So r is equal to, how can I get this r? I can simply divide both sides by z e square pi m, z e square pi m. So this term will be cancelled with this term. So we are left with r is equal to epsilon naught n square h square epsilon naught divided by z e square pi m. Now students, this equation is very important. ये जो equation है students, ये बहुत ज़्यादा important है. Why? Because this r will give us these values will give us the value of r. How? For example, we know that now students, Planck's constant is equal to 6.62 into 10 raised to the power minus 34 joule second. Right? We have the value of E is charge on electron 1.6022 into 10 raised to the power minus 19 coulomb. Epsilon naught is 8.85 854 into 10 raised to the power minus 12 coulomb square per Newton per meter square. Right, students? And we have the mass of electron which is equal to 9.11 into 10 raised to the power minus 31 kg. Right, students? And we have pi which is 3.14. So putting all these values over here, we will get n square into this okay, z is equal to 1 for hydrogen, right, student? So if I put all these value comes to be 0.529 angstrom. ठीक है स्टूडेंट्स, इनको याद करने की जरूरत नहीं है, मैंने वैसे लिख लिए. there is no need to learn these. Just from here you can simply say that this value is equal to h square epsilon naught ze square pi m is equal to 0.529 angstrom plus a, and z is equal to 1. Okay? Now students, this we got a formula. ये वो फार्मूला है जहाँ पे हम R की वैल्यू को कैलकुलेट कर सकते हैं. We can calculate the value of R of hydrogen atom. ठीक है स्टूडेंट्स? हाउ? देखिए. Now students देखिए सर. We know that R is equal to n square divided into 0.529 angstrom. Angstrom is the unit. 1 angstrom, 1 meter is equal to 10 raised to the power 10 angstrom. Yeah, 1 angstrom is equal to 10 raised to the power minus 10 meter. Remember this. Let n is equal to 1. n is equal to 1 का मतलब है shell number 1. Shell number 1. So let R1 will be equal to 1 square into 0.529 angstrom. So R1 is equal to 0.529 angstrom. इसका मतलब क्या है? इसका मतलब है कि the radius, first radius of hydrogen atom का first radius कौन सा है? Number 1 radius, उसकी वैल्यू क्या है? वो है 0.529 angstrom. The radius of hydrogen atom is 0.529 angstrom. Now if n is equal to 2, if n is equal to 2, it means if the electron is excited. So what will be the radius then? So R2 will be equal to n2 n, okay, n is equal to 2, then R2 is equal to n square into 0.529 angstrom, which means that R2 is equal to 2 square into 0.529 angstrom. R2 is equal to 4 into 0.529 angstrom. Similarly, R3 is equal to 3 square into 0.529 angstrom, which is equal to R3 is equal to 9 into 0.529 angstrom. R4 कितना होगा? 16 into 0.529 angstrom. Right students? Okay. अब NMDK में ईटा में हमेशा सवाल आता है कि how much times is the second radius more than the first radius of hydrogen atom? So remember 4 times. कितना? 4 times. Look, R1 कितना है? मैं यहाँ पे लिखता हूँ. R1. How much is R1? R1 is 0.529 angstrom. How much is R2? R2 we calculated over here. It is 4 into 0.529 angstrom. How much is R3? R3 is 9 into 0.529 angstrom. R4 is 16 into 0.529 angstrom. Now, R2 is 4 times more than R1. R3 is 9 times more than R1. R4 is 16 times more than R1. मतलब क्या है कि R1 हमारे पास उसका रेडियस, R1 हाइड्रोजन का जो पहला शेल है उसका जो रेडियस है वो है 0.529 एंगस्ट्रॉम. जो सेकंड है वो 4 टाइम्स बड़ा है पहले वाले से. जो थर्ड है वो 9 टाइम्स बड़ा है पहले वाले से. एंड जो फोर्थ शेल है हाइड्रोजन एटम का वो है 16 times more than the first release. ठीक है स्टूडेंट्स, आई होप यू विल गेट द लेक्चर. ये थोड़ा सा कॉम्प्लिकेटेड है, लेकिन स्टूडेंट्स इसमें आप जितना प्रैक्टिस करोगे इंशाल्लाह उतना ही आप सीख सकोगे. सो डू more practice on this type of questions, so you will learn inshallah. Thank you. Welcome back students again. Chapter number 2, topic is energy difference. Energy difference between two shells. We have two orbits, right students? This is very easy, a very simple and easy topic. Remember students, let me draw. This is the nucleus, shell number 1. Let's suppose this is shell number 2. This is E1, N1. This is N2. Right students, the energy of shell number 1 is E1, the energy of shell number 2 is E2, and we know that change in energy is equal to hν. Keep this equation in your mind students. We have to use this equation very soon. We know that students, the energy of electron is En is equal to negative E4 m divided by 8 epsilon naught square h square into z square by n square. ये हमने अभी प्रूव कर लिया. Right students, and we know that z is equal to 1 for hydrogen atom. अभी हमने इसको प्रूव कर लिया. I can write this equation and this way as well. Negative 1312.36 into z square by n square, or negative 1312.36 divided by n square. This is the energy of electron. Now energy of electron in shell number 1. In shell number 1 it is E1. E1 में कितनी एनर्जी है? It is negative 1312.36 divided by n1 square. E2 में कितनी है स्टूडेंट्स? It is negative 1312.36 divided by n2 square. Energy difference कितना है students? Energy difference is equal to E2 minus E1. Put the values. E2 is negative 1312.36 divided by n2 square minus n2. E1 is negative 1312.36 divided by n1 n square. Simply students, I can write negative 1312.36 divided by n2 square minus plus 1312.36 divided by n1 square. On the rearranging this equation, I can rearrange this equation. This equation can be rearranged, and this way write this one first and this one second. This is the rearrangement, n1 square minus 1312.36 divided by n2 square. From where I get this minus sign is this one. मैंने पहले ये लिख लिया और बाद में ये लिख लिया. Simple as this. Now take common 1312.36. So if you take common 1312.36, this equation becomes 1 by n1 square minus 1 by n2 square. Right students? इसमें कोई confusion है? नहीं जी. तो देखो, change in energy, we know that is equal to hν, and we know that it is equal to 1312.36 into 1 by n1 square minus 1 by n2 square. Right students? याद रखिए students, एनर्जी जो है नेगेटिव साइन है, एनर्जी चेंज में नेगेटिव साइन नहीं है, पॉजिटिव साइन है। देखो चेंज, इसको याद रखें स्टूडेंट्स। अच्छा स्टूडेंट्स, यहाँ पे मैं लिख सकता हूँ 2.18 × 10⁻18 जूल, यहाँ मैं लिख सकता हूँ 13.6 इलेक्ट्रॉन वोल्ट। ठीक है स्टूडेंट्स, इक्वेशन के लिखने के डिफरेंट तरीके हैं। इस तरह लिख सकता हूँ या मैं इस तरह लिख सकता हूँ। देखिए स्टूडेंट्स, 13.6 इलेक्ट्रॉन वोल्ट यूनिट n1 स्क्वायर माइनस 1/n2 एक तरीका ये है। एक दूसरा तरीका ये भी है 2.18 × 10⁻18 -18 जूल 1/n1 स्क्वायर माइनस 1/n2। और जी एक और तरीका भी है, एक और तरीका भी है। किस तरह लिखना है? इसकी जगह ये लिखो क्या, E4m डिवाइड बाई 8 एप्सिलॉन नॉट स्क्वायर h स्क्वायर n2 z स्क्वायर बाई n स्क्वायर। अच्छा ये स्टूडेंट्स ये n स्क्वायर लिखने की ज़रूरत नहीं है और न z लिखने की ज़रूरत है। हम क्या करें, हम इसको लिखेंगे क्योंकि हम ऑलरेडी इसको सॉल्व कर चुके हैं। 1/n1 स्क्वायर माइनस 1/n2 स्क्वायर। राइट स्टूडेंट्स, अब देखो दिस h न्यू इज इक्वल टू E4m डिवाइड बाई 8 एप्सिलॉन नॉट h स्क्वायर 1/n1 स्क्वायर माइनस 1/n2 स्क्वायर। इस h को इस साइड पे लेके आओ। ठीक है, डिवाइड h on both sides, so you cancel. This is new is equal to E4m divided by 8 epsilon naught h square. This is epsilon naught square h square and to h, so h cube now, h cube into 1/n1 square minus 1/n2 square. अब इसका यूनिट क्या होगा जी? हर्ट्ज होगा। Now this is used to find the frequency of radiation. Frequency of radiation. Right students, next. अब इसमें बहुत कम काम रहेगा स्टूडेंट्स। देखिए सर, मेरे पास इक्वेशन है, एक इक्वेशन है मेरे पास, वो है दिस न्यू इज इक्वल टू c ओवर लैम्डा। तो मैं इसकी जगह यहाँ पे c बाई लैम्डा डाल दूंगा। लो, न्यू इज इक्वल टू दिस, सो न्यू की जगह आई विल पुट c बाई लैम्डा। व्हाई? बिकॉज आई नो दिस इक्वेशन। ओके स्टूडेंट्स, सो आई कैन राइट c बाई लैम्डा इज इक्वल टू E4m divided by 8 epsilon naught square h cube and 1/n1 square minus 1/n2 square. Now students, shift c to this side. It will change to our lambda is equal to E4m divided by 8 epsilon naught square h cube and c. Right students? And 1/n1 square minus 1/n2 square. Students, we know that 1 by lambda is equal to wave number. So I can put over here wave number is equal to E4m divided by 8 epsilon naught h cube c n2 1/n1 square minus 1/n2 square. And students, this value E4m divided by 8 epsilon naught h cube c is equal to r, is equal to r 1/n1 square minus 1/n2 square. Let me write over here again. देखिए स्टूडेंट्स, इक्वेशन wave number is equal to r 1/n1 square minus 1 by E n2 square, and this R is called a Rydberg constant. Rydberg constant, and its value is 1.0974 into 10 raised to the power 7 per meter. 1.097, simply 1.0968 into 10 raised to the power 7 per meter. ये नंबर है स्टूडेंट्स, तो पर मीटर, और हमें पता है कि R किसके बराबर है? R बराबर है, यहाँ पे देखो, E4m डिवाइड बाई 8 एप्सिलॉन नॉट स्क्वायर h क्यूब mc, और इसकी वैल्यू है 1.097 या 68, आई थिंक इट इज 7.0968 मैंने लिखा है, ठीक है, 68 into 10 raised to the power 7 per meter. राइट स्टूडेंट्स, अच्छा यहाँ ये जो पोर्शन है ये बहुत इंपॉर्टेंट है, यहाँ से ईटा में बहुत सवाल आता है. फॉर एग्जाम्पल एक सवाल आया है कि व्हाट विल हैपन टू द वैल्यू ऑफ R if we decrease E by half. अगर हम E को हाफ कर ले तो R के वैल्यू पे क्या असर होगा? आई रिपीट स्टूडेंट्स द क्वेश्चन, if we half the value of E, so what will happen to R? शाबाश. So मैं ऑप्शन दे रहा हूँ, if E is half, this E is half, then the value of R क्या होगा? मैं ऑप्शन दे रहा हूँ, चलो मैं आंसर डायरेक्ट आंसर दे रहा हूँ. It will reduce by 16 times, reduced by 16 times. ये क्यों 16 times? देखो स्टूडेंट्स, ये E है ना, E by 2 है, और इसके ऊपर क्या है? 4 है, तो 2 multiply 2 कितना आया? 2 2 4, 4 2 8, 8 2 16. सो E by 16 होगा क्या? नहीं होगा. तो E by 16 मीन E जो है 16 टाइम डिक्रीज हुआ, ठीक है, तो R क्या होगा? 16 टाइम्स डिक्रीज हो जाएगा, सॉरी नेक्स्ट 16 टाइम्स. अगर E 2 टाइम डिक्रीज हुआ तो R कितना हो जाएगा? 16 टाइम्स डिक्रीज हो जाएगा, 16 टाइम डिक्रीज हो जाएगा. अगर हम M को हाफ कर ले तो क्या होगा? If we half M, the value of R will be half. If we double E, so the R value increase 16 times. Alright students, these were a few questions which were in the ETA in the past, from the past papers. If you have any question regarding this topic, so simply you can approach me, and inshallah I will have to solve all the problems regarding this topic. Remember students, this topic is very complicated, it needs more practice. If you practice more and more, you will get this topic. It's a very simple topic but a bit confusing, and if you practice more and more, then I hope कि आप लोग इसको pick कर लेंगे बहुत आसानी से. Thank you very much. Welcome students. Again we are going to discuss chapter number 2, and the topic for today's discussion is the derivation of energy of electron in an orbit. The derivation of energy. So let's start the topic students. We know that the total energy of electron is total energy. Note that total energy of electron is equal to the sum of kinetic energy plus potential energy. Alright students, what is kinetic energy? The energy due to the motion of the body is known as kinetic energy. So the energy due to the motion of electrons, force of attraction, there is a force of attraction between the proton and the electron. Electron lighter is a lighter particle, and proton being 1836 times heavier than electrons, so it remains stationary, and the electron it revolves around the nucleus, and the nucleus around the nucleus and shells. So this is called kinetic energy. kinetic energy is equal to half m, and we know that kinetic energy is equal to half mv square. Kinetic energy is equal to half mv square. Half mv square. Remember, students, this formula. This is the kinetic energy of a electron while it rotates and orbits around the nucleus. Another point, what is potential energy? The energy due to the position of a body is known as potential energy. In this case, what is potential energy? The energy bringing the electrons from infinity towards a position where there is a force of attraction between the nucleus, mean the protons and electrons. क्या मतलब? Let we have, this is our nucleus, right students? Nucleus of hydrogen atom, and this is the shell of hydrogen atom, and the electron is over here. Now if the electron is excited and it moves to a position where there is no force of attraction between the electron and the nucleus, we call that position as infinity. Let's suppose this is a position, we call that position as infinity. Infinity is a position when there is no force of attraction between the electron and the nucleus. At infinity, there is no force of attraction between the electron and the proton. Students, as we know that when we move away, when the electrons move away from this positive charge, potential energy increases. At infinity, we assume that it is zero. We assume it is zero. It is a value, and that is a standard value. Let me give a standard value of 0. At infinity, the potential energy of electron is 0. So when it moves from this electron, when this electron moves from this positive charge, the potential energy increases. You see, the potential energy is the energy to the position. So the potential energy increases. But when it comes from infinity towards a position where there is a force of attraction, suppose over here. Now over here there is a force of attraction between this electron and this nucleus. So from coming from infinity to this shell, the energy of electron decreases. Energy of electron decreases. Remember, the energy of electron decreases, and we know that potential energy is equal to force into distance. It's the work done. And a negative sign. Why a negative sign? As I told you, when the electrons from infinity comes towards a position, there is a force of attraction, so the energy decreases. So we will put the negative sign. This distance is the radius of the atom. So potential energy is minus F into R. And students, we know that this F is the force of attraction between the electron and proton. And we know that this F is equal to, let me write the formula over here. This F is equal to 1 by 4 pi epsilon naught into ZE square divided by R square. Alright students, so now we have the values of kinetic energy as well as we have the value of potential energy. So let's put the value. Total energy total is equal to kinetic energy plus potential energy. Kinetic energy is equal to half mv square, and potential energy is equal to this, and force of attraction multiplied by r. So look, we have to put this value first over here. So negative 1 by 4 pi epsilon naught into ze square divided by r square into r, because I want to find the value of potential energy first. So this r is cancelled with this r, so potential energy is equal to 1 r is left, remember students, minus 1 by 4 pi epsilon naught into ze square divided by r. So let's put this value over here. It is minus 1 by 4 pi epsilon naught into ze square divided by r. Students, 1 by 2 mv square, and it is plus into minus is minus 1 by 4 pi epsilon naught into ze square by r. Remember students, we have the value of mv square. We have the value of mv square, and the value of mv square is ze square. We have derived this value in the earlier equation, that is the radius of hydrogen atom, right students? ये वैल्यू हमने डिराइव की थी कहाँ पे? रेडियस ऑफ हाइड्रोजन एटम में। ये हमें पता है कि इसकी वैल्यू क्या है। शॉर्टकट बताता हूँ, इसकी जो वैल्यू है वो एग्जैक्टली इस तरह है। जो ये वैल्यू है एग्जैक्टली वही वैल्यू यहाँ पे, ठीक है? तो जस्ट पुट इट ओवर हियर, इट इज z1 into z is ze square डिवाइड बाई, मैं इसको भी इसी तरह कर लेता हूँ ताकि कंफ्यूजन खत्म हो जाए, ze square डिवाइड बाई 4 पाई एप्सिलॉन नॉट r। मैंने एक साथ लिख दिया, वो एक चीज़ है, देखो मैंने मल्टीप्लाई किया बस, ठीक है? दिस वैल्यू इज mv square इज इक्वल टू इसी के बराबर है। रिमेंबर, ये शॉर्टकट है, आपको याद करने की जरूरत नहीं है। ये जो वैल्यू है mv square इसी के बराबर है। ये ऑलरेडी हमने प्रूव किया हुआ है एंड द बैक इक्वेशंस। कहाँ पे? रेडियस ऑफ हाइड्रोजन एटम में, ठीक है स्टूडेंट्स? आप वहाँ से चेक कर सकते हैं। दिस इज 4 पाई एप्सिलॉन नॉट r माइनस ze square डिवाइड बाई 4 पाई एप्सिलॉन नॉट इन r। राइट स्टूडेंट्स, इन दोनों को मल्टीप्लाई करें तो ये बन जाएगा ze स्क्वायर डिवाइड बाई 8 पाई, ये 1/2 इसके साथ मल्टीप्लाई हो जाएगा, एप्सिलॉन नॉट r माइनस ze स्क्वायर डिवाइड बाई 4 पाई एप्सिलॉन नॉट इन r। ओके स्टूडेंट्स, अब क्या करेंगे हम इनकी यहाँ पे मैं आ रहा हूँ, ठीक है? एलसीएम लेंगे, क्या लेंगे? एलसीएम। एलसीएम क्या होगी स्टूडेंट्स? एलसीएम होगी 8 पाई एप्सिलॉन नॉट r। यार अगर हमारे पास 8 हो और 4 हो, मैं कहूँ कि एलसीएम ले लो तो देखो 4 2s are 8 and this is 1 and 2 2s are 2 1s are 4 into 2 is 8, it is the LCM। ये वही मैथ्स है, सिंपल मैथ्स है, ठीक है? राइट स्टूडेंट? ओके, नाउ कम्स टू द टॉपिक 8 पाई एप्सिलॉन नॉट r। तो यहाँ पे आएगा ze स्क्वायर माइनस, और यहाँ पे आएगा 2ze स्क्वायर। Why 2ze square? Because the LCM is 8. The LCM is 8. Right student? So 4 2s are 8. So 2ze square is 2ze square. Right students? या एक सिंपल तरीका ये है कि इसको 2 से मल्टीप्लाई करो और डिवाइड करो, मल्टीप्लाई एंड डिवाइड बाई 2। So nothing is happening to the equation. So ये इक्वेशन बन जाएगा 2ze square and 8 pi epsilon naught r. ठीक है, इस तरह भी कर सकते हैं. So we will get over here minus ze square divided by 8 pi epsilon naught and r. This is what energy of electron. Now students, one more thing. The thing is that we know the value of r, right students? This value of r we have to put. Now students, we know the value of r, so we have to put the value of r in this equation. Why? Because the energy of electron is different in different shells. So for that reason we have to put the value of r. We have to replace r by some factor, and the factor is, we know that the value of r is equal to, r is equal to this, r is equal to, from equation 2.8. आपके बुक में equation 2.8 देखिए जरा, ठीक है. इक्वेशन 2.8 में है कि r is equal to, याद रखिए स्टूडेंट, is equal to n square h square epsilon naught divided by ze square pi m. This is what? This is the value of r. So we have to put this value in the equation, this one. So now energy of electron is equal to minus ze square divided by 8 pi epsilon naught, और r की जगह क्या लिखेंगे? n square h square epsilon naught divided by ze square pi m. Alright students, तो क्या होगा? ये जो पोर्शन है ये ऊपर चला जाएगा, ये इक्वेशन चेंज हो जाएगा. इट विल चेंज टू e is equal to minus ze square into ze square pi m divided by 8 pi epsilon naught n square h square epsilon naught. Alright students, अब देखिए जरा इक्वेशन को जरा देखिए स्टूडेंट्स, क्या होगा? स्टूडेंट्स, बी केयरफुल, यू हैव टू गो स्टेप वाइज, एंड प्लीज यहाँ पे आप थोड़ा सा ध्यान दें. ये इतना मुश्किल नहीं है, जस्ट आपने थोड़ा सा ध्यान इसकी तरफ देना है और इसको गौर से देखना है. तो ये इक्वेशन चेंज हो जाएगा इनटू E इज इक्वल टू, E इज व्हाट? एनर्जी इज इक्वल टू माइनस z स्क्वायर E4. Why z square? Because z into z at z square, e square into e square is E4, and pi m, this is pi m divided by 8 pi epsilon naught square. It's epsilon naught square. Right students? And n square and h square. Now simply we can cut this e. The equation becomes negative z square e4 m divided by 8 pi epsilon naught square n square h square. Z is equal to 1 for hydrogen. This equation becomes E is equal to negative E4m divided by 8 epsilon naught square h square में n square को यहाँ पे, ये n square में क्या कर रहा हूँ? अलग लिख रहा हूँ. इक्वेशन पे कोई असर नहीं पड़ा. What I did, I just separate the equation, the n square from the equation for a reason. Right students? Now student, remember this portion E4m 8 epsilon naught square h square, it is a constant. It is constant, and if we put the values of epsilon naught, h, e and m and the equation, this will give you a value, and the value is 2.8. Negative 2.8 into 10 raised to the power minus 18. Right students? Divided by n square. The unit is joule. So remember students, E4m divided by 8 epsilon naught square h square is equal to 2.18 into 10 raised to the power minus 18 joule. So yeah, we can calculate this value students to kilojoule per mole. If you want to convert it into kilojoule per mole, simply you have to multiply with Avogadro's number and divide by 1000, so it will give you kilojoule per mole. So after doing that, E is equal to negative 1312.36 divided by n square, and the unit will be now kilojoule per mole. This unit is joule per atom. Remember, this is joule per atom. It is kilojoule per mole. We have another value as well. E is equal to negative 130.6 electron volt. We have another value for energy that is equal to negative 13.6 electron volt. Remember students, all of them they are equal. But this is joule per atom, this is kilojoule per mole, and this is electron volt. Thank you very much students. Okay, coming back students to the topic. We know that the energy of electron is negative 1312.36 kilojoule per mole divided by n square. So if I tell you to calculate the energy of electron in the first shell, so E1, right, is negative 1312.36 and n की जगह आप 1 डालो, 1 square. So energy of electron in the first shell is negative 1312.36 kilojoule per mole. This is the energy of electron in the first shell. Energy of electron in the first shell of hydrogen atom. Continue to calculate the energy of electron in the second shell, E2. So it will be negative 1312.36 divided by n square की जगह हम लिखेंगे 2 square. So it will change to negative 1312.36 divided by 4, and it is approximately is equal to minus 328 kilojoule per mole. Right students, it is approximately equal to negative 328.32. To be more accurate, 0.32. This is the energy of electron and the second shell. Similarly, energy of electron and the third shell, E3, it will be equal to negative 1312.36 divided by n square. So n 3 square, and 3 square is 9. So negative 1312.36 divided by 9, and the value is negative 145.92. Negative 145.92 kilojoule per mole. This is the energy of electron in third shell. Alright students, तो आप मुझे बताएं कि एनर्जी जो है ये कम हो रही है या ज़्यादा हो रही है स्टूडेंट्स? शाबाश. Yes, energy of electron decreases. No, energy of electron increases. Energy of electron increases, not decreases. क्यों? क्योंकि नेगेटिव साइन है. नेगेटिव साइन का मतलब है कि नेगेटिव साइन की वजह से इसका मतलब है कि नेगेटिव साइन कम होता जा रहा है. Look, over here negative 1300 somewhere, and over here negative minus negative 328. So ये वैल्यू इंक्रीज हो रही है. नेगेटिव ये नेगेटिव 1300 है और ये नेगेटिव 300 है. तो नेगेटिव 300 ज़्यादा है नेगेटिव 1200 से, और नेगेटिव 300 से फिर नेगेटिव 145 ज़्यादा है. Right students? So the energy increases. Energy इंक्रीजेस शेल नंबर 1 की जो एनर्जी है वो कम है, शेल नंबर 2 की एनर्जी शेल नंबर 1 से ज़्यादा है, एंड शेल नंबर 3 की एनर्जी शेल नंबर 2 से ज़्यादा है। अब एक काम करते हैं स्टूडेंट्स, एक काम करते हैं जी, चलो जी। अब आप लोगों से मैं एक सवाल पूछता हूँ, आप लोगों ने मुझे जवाब देना है, ठीक है स्टूडेंट्स। अब मुझे बताओ कि E2 माइनस E1 बड़ा है या E3 माइनस E2 बड़ा है या E4 माइनस E3 बड़ा है। चलो जी, व्हाट डू यू थिंक, क्या ख्याल है कौन सा बड़ा होगा? सो लेट मी कैलकुलेट दिस वन फॉर यू पीपल। E2 कितना है? E2 एनर्जी ऑफ इलेक्ट्रॉन इन सेकंड शेल इज माइनस 328 माइनस इनटू E1 कितना है? माइनस 13 12.36। सो ये माइनस 328 माइनस माइनस प्लस 13 12.36। तो अगर आप देखें तो इससे तकरीबन 980 समवेयर के करीब आती है, 83.46 किलो जूल पर मोल। अगर आप यहाँ पे देखें सो E3 कितना है? नेगेटिव 145 प्लस इतना, तो ये वैल्यू 300 है, प्लस 300, तो ये वैल्यू कम आ रही है। सो रिमेंबर स्टूडेंट्स, E2 माइनस E1 इज द हाईएस्ट ऑफ these two, and these three highest energy difference is E2 minus E1. Alright students, thank you very much. Next lecture is about the frequency wave number and etc. Okay.